So in this video, we're going to be dealing with simplifying radicals. So when you want to simplify a radical, you need to find the perfect square or perfect cube, depending on the index. So in this one, we're doing square roots, where index is just 2. A perfect square that divides evenly into 20. So 20 could be written as 2 times 10, but neither of those is a perfect square. But if you write it as 4 times 5, 4 is a perfect square. So you could separate these and just write it as the square root of 4 times the square root of 5. Now, because 4 is a perfect square, when we simplify, the square root of 4 is just 2, and that gets multiplied by the square root of 5. In this one, we already have a number or a coefficient in front. We are still breaking down the square root of 75. So 75 is 25 times 3. So you can write that separately as the square root of 25 times the square root of 3. 25 is our perfect square. The square root of 25 is just 5. And then it gets multiplied by 3. So 4 times 5 will give us a coefficient of 20 multiplied by the square root of 3. So if you have a number in front or a coefficient, you just do the same process, break down your 75, and then multiply it by your coefficient of 4. So in this one, we have the cube root of 24. So we're not trying to find a perfect square, we're trying to find a perfect cube that divides evenly into 24. So unlike doing factor trees where you can pick any two numbers that multiply to give 24, in this case we want to make sure it's a perfect cube. So 8 is a perfect cube, and 8 times 3 is 24. The cube root of 8 is 2, and that gets multiplied by the cube root of 3. So the cube root of 24 is equivalent or equal to 2 times the cube root of 3.